Hello everybody, we are from Group 11 of Division B and I am Prasanna Bhalarao and today we are presenting the basic instruction and execution cycle. First of all, let me introduce my team. Yash Bhalarao, myself Prasanna Bhalarao, Kush Bhakkad, Parth Bhalarao, Yash Bhale and Amay Bhagwatkar. Now moving towards the introductory slide, the basic instruction execution cycle, also known as fetch execute cycle or instruction cycle, is a fundamental process followed by a CPU from boot up to shutdown. It basically used to process instruction. The main stages are, the very first one is fetch stage. The CPU fetches the next instruction from memory. The second is decode stage. The fetch instruction is decode, determining the operations to be performed and extracting necessary operands and addresses. The next is the execute stage. The CPU performs the operations indicated by the instruction. The next is WriteBack stage. The result of the execution are written back to memory or register. The next is, in simple CPU, the instruction cycle is executed sequentially, meaning each stage completes before moving to next. In modern CPU, the instruction cycle is executed concurrently with multiple instructions being fetched, decode and execute simultaneously, using techniques like pipelining and out of order execution. The basic instruction execution cycle is crucial for processing instruction and forms the backbone of the computer operations, allowing programs to be executed and tasks to be performed efficiently by the CPU. Instruction execution cycle. In the computer, each instruction cycle includes the following procedures. First, it can fetch instructions from the memory. Second, it is used to decode the instruction. Then it can read the effective address from the memory if the instruction has an indirect address. Third, it can execute the instruction. And last, it can write back. So let's talk about the first stage, which is the fetch process. The fetch process is a crucial step in the execution cycle of a computer's central processing unit. It involves retrieving the next instruction from the memory and preparing it for further processing. The fetch process is the same for instruction. The CPU sends the content of the PC to the MAR and sends a read command on control bus. In response to read command with address equal to PC, the memory returns the data stored at memory location indicated by the PC on the data bus. The CPU copies the data from the data bus into its MDR. A fraction of a second later, the CPU copies the data from the MDR to instruction register for instruction decoding. The PC is incremented so that it points to the next instruction. This step prepares the CPU for the next cycle.
Hi everyone, I am Yash Bhalarao. I will be explaining the decode process. The decode step is the second step in the instruction execution cycle following the fetch step, and it precedes the execute step. Decode refers to the step in the instruction execution cycle where the CPU interprets an instruction. It determines what data is retrieved, the operation that is specified, where the result is stored. Once the CPU has decoded the instruction, it proceeds to the execute step. The detailed steps in decode process are: first, retrieve the instruction from the instruction register IR, extract the operation code which specifies the operation to be performed, extract any required operands or data from the instruction, generate control signals based on the opcode and operand information, identify and access any necessary registers. Proceed to the execution phase to perform the specified operation.
Hello, myself Kush Bhakkad and I will be explaining the execute cycle. So, the CPU carries out instructions by fetching the operands from memory and sending them to the ALU to be executed. Once complete, the resulting value is stored in a memory location for use by the program at a later stage. Inside every computer is a chip known as the Central Processing Unit or CPU. Its job is to execute instructions given from the software by fetching the operands from memory and sending them to the arithmetic logical unit, that is ALU, to be processed. The ALU then performs an operation based on the program instruction and outputs the result. This is what is shown in the current diagram. It shows the execute cycle in the program. Each instruction consists of an operation to be executed and 0, 1 or 2 operands or pieces of information that are referenced with the memory. The operand fetch stage is responsible for obtaining the data or memory address from the source code. Once the operand fetch completes its work, the processor can then pass the value to the execution unit, which actually carries out the decision operation. By understanding how the execute process of the CPU works, we can start to understand how computers are able to carry out instructions. Inside the CPU, there is a special component known as the ALU or arithmetic logic unit. This is where all the calculations are done. The ALU processes instructions by taking in the values from the two memory locations. It then performs an operation based on the program instruction and outputs the result. This process is known as the ALU operation. The instructions are executed one by one until the program is completed or any error is encountered. So now let's take a closer look at the result storage. It's an important and final step of the execute process, and it is where the result of the previous steps are stored. Here, the results are collected, organized, and stored in a way that makes them easily accessible and retrievable. This helps to ensure that any future work is based on accurate and up-to-date information. The result storage section is an important part of the execute process. It ensures that the ideas generated have a long-lasting impact and that the results are preserved for future use. This is what is the execution cycle process.
Hello, myself Yash Bale. I will be explaining about fetch execute cycle. The fetch execute cycle is a fundamental process in computer central processing unit where instructions are fetched from memory and are decoded and then executed. It involves four main steps. First is fetch, second is decode, third is execute, and fourth is update. In the fetch step, the instruction is retrieved from the memory. In the decode step, the CPU interprets the instruction's copy code. In the execute step, the operation specified by the instruction is performed, and finally in the update step, the program counter is adjusted to fetch the next execute cycle. Then this cycle repeats for each instruction, allowing the CPU to execute the program. After this, the next process is write-back process. After the execution phase of an instruction, the CPU obtains a result or an output based on the operation performed. The CPU identifies the destination where the result needs to be stored. This depends on the type of instruction and its encode. If the destination of the result is a register, the CPU updates the identified register with the obtained result. In case the destination of the result is a memory location, the CPU initiates a memory write operation. And with the result extracted, the destination identified and the necessary updates made, the CPU finalizes the execution of the current instruction. So in this way, the write-back process works.
Hi, my name is Amay and I will be explaining the illustration steps in computer instruction and execution programs. The first step is MDR out. During this stage, the processor retrieves the next instruction from memory. The first instruction or operand is stored in the memory data register. Is also called as MDR. The MDR acts as a temporary holding place for the data fetched from memory. By outputting the contents of the MDR, we make the fetched data available for further processing in the upcoming steps of execution cycle. The second step is IRing. After the instruction or operand is stored in the MDR, it is transferred to the instruction register or IR for further processing. The IR holds the fetched instruction and it is crucial component for decoding the instruction. The control unit of the processor examines the instructions stored in the IR and decodes. The stages are three out. Registers are small, high-speed memory until within the processors that temporarily store data during the execution of instruction. In this step, we specially output the content of registers R3. R3 is just one of many registers in a processor, and its purpose may vary depending on the program being executed. By outputting the content of R3, we make the data stored in that register available for using subsequent stages of execution cycle. And fourth stage is MAR address register. It is responsible for holding the memory address that needs to be accessed. In this step, we load the MAR in the appropriate memory address. The specific memory address is determined based on the instruction being executed or the operation being performed. By loading the MAR with the correct order, we indicate which memory location should be accessed for the data retrieval or storage. And thank you for listening our presentation.